So in this section of the subject, we're going to look at climate and weather. So let's start with our atmosphere. And the atmosphere has different layers. It has layers called the troposphere, the stratosphere, the mesosphere, the thermosphere, and then the exosphere. So let's start with the troposphere. Now, tropos means change, and there's a lot going on in this layer. It's the layer closest to the Earth's surface, it's the one that we exist in, and it's the one where weather occurs. So there's a lot changing, weather is changing, and it is the layer that has the densest part of the atmosphere, the highest air pressure. This layer extends up to about 12 kilometres above the Earth's surface. So when we talk about weather and climate, this is the layer that we're going to be examining most. The troposphere contains 75% of all the air in the atmosphere and almost all of the water vapour, which is where our clouds and our rain comes from. In this part of the atmosphere, the composition of the air that we breathe is 78% nitrogen, 21% oxygen, and then tiny amounts of other gases, including gases like carbon dioxide, which has about 0.03% of the atmosphere. Just interestingly, the air that we breathe, we need the oxygen to survive, but most of what we breathe in and then breathe out is nitrogen. And we do in fact just breathe it in and breathe it out exactly the same way. Its composition doesn't change. It's inert. We do nothing with that nitrogen. But interestingly, nitrogen is really important for our bodies. We need it to live. It's important in our proteins and other functions in our body. And where do we get that nitrogen from? We're surrounded by it in the atmosphere, but we can't use it. And plants are surrounded by it, and they actually can't use it either. We get the nitrogen mostly from plants and from animals that eat plants. But where do they get it from? They can't use it. They don't breathe it in. Plants don't just get it from the atmosphere. It's a really interesting concept. And if you do a subject with me on soils, you'll find the answer. Let's move on to the next layer. Let's move on to the stratosphere. Now, stratosphere means layered, and in the stratosphere, it has its own different layers as well. The boundary between the troposphere and the stratosphere is called the tropopause, and that's where most aeroplanes fly, high international flights, if they're ever allowed to fly again. It extends up to about 50 kilometres above the Earth's surface, and it's in this layer where the ozone layer occurs. So the ozone layer is made up of O3 molecules, and it's the layer that absorbs the ultraviolet radiation from much of the ultraviolet radiation from the sun, and protects life on Earth from that ultraviolet radiation. Now, you probably have heard of the ozone layer before, and if you're my age, when you were growing up, it was a real problem. Well, the layer wasn't a problem, but humans causing a large hole in the ozone layer. As that hole, which began around the Antarctic, as it expanded, it was going to let in a whole lot more ultraviolet radiation and cause lots of problems for life on Earth. And the reason it was becoming larger was the release of a chemical called chlorofluorocarbons, which was in many aerosols, and it reacted with the ozone, broke it down, and made the hole larger. It's a good example of what you can do when global cooperation occurs. So countries got together and banned the use of chlorofluorocarbons, many of which also occurred in refrigerants. And that required a huge change in the manufacturing processes of many of our products. But we did it. And now the hole in the ozone layer has shrunk, and it's a really good example of what we can do when we want as a globe. If only we could do the same with climate change. Maybe a bit later on. Above the stratosphere is the mesosphere, and meso means middle, and the layer extends up to 85 kilometres above the Earth's surface, and the boundary between the stratosphere and the mesosphere is called the stratopause. In this layer, there's very few air molecules, so the air density has decreased. Okay, the further up you get, the air density decreases. But there's just enough air density to cause friction when meteors enter that layer of the Earth's atmosphere, and that's what you see when you see a shooting star. That's that meteor burning because of the friction with the air particles in the mesosphere as it flashes across the sky. Above the mesosphere is the thermosphere, and in this layer, temperatures are extremely high, much higher than what they are on the Earth's surface. And we'll see why a bit later on when we look at the change in temperature with altitude in the atmosphere. And it extends up to 700 kilometres above the Earth's surface. And most people sort of stop at this layer and they say that's the edge of the Earth's atmosphere. And interestingly, in the thermosphere, you may have heard of the northern lights or the southern lights, the aurora or aurora borealis. It's in that layer that incoming radiation from the sun ionizes with the gases that are in that thermosphere. Not very dense, but there are some gases up there that react with the radiation from the sun and flash in these lovely patterns. I've never seen them. Apparently you have to be very far south and very far north to be at the right angle to see the ionizing particles, but that's due to what's happening in this layer, the thermosphere. The last layer that we can look at is called the exosphere, which is just the layer that is just the boundary between what we can call the Earth's atmosphere and space. So this layer extends as far as you like. Where you define the edge is up to you, how you define space from the atmosphere. It's not a hard boundary. It just grades eventually into space and the air molecules escape and go on their way through space. So it extends up to 10,000 kilometres above the Earth's surface. Okay, so let's now have a look at how temperature changes in the atmosphere. Let's start at the Earth's surface. So we know that it's about 20 degrees, about 16 degrees is the average temperature of the Earth. Now, the heating effect, as we'll see a little later on, that part of the atmosphere, the one that we live in, is heated by the radiation coming off the Earth's surface. So the sun, as we will see, the radiation, incoming solar radiation comes in, warms the Earth, and then that re-radiates out as heat that heats the atmosphere. So it's warmer at the bottom of the atmosphere. And we know that, warmer at the bottom of the troposphere. As you go up, the temperature decreases, and we know that that's the case when we go up a mountain. Now there are a couple of reasons why it cools as you move with altitude. One is that you're moving further away from that source of heat in the Earth. The other has to do with changing air pressure, and we'll look a little bit more at that later on. So the temperature decreases the further away you get from the Earth's surface. Now you might think that that would continue all the way out to the exosphere, but it doesn't. In the tropopause, something happens, and then you move into the stratosphere, the temperature starts to increase again. Why is that? And that's because of that layer of ozone that we saw before. So the ozone layer not only stops UV radiation coming in, it also absorbs some of the solar radiation from the sun and re-radiates that out as heat. And so the closer you get now to its source of energy, which is the sun, okay, not the Earth's surface anymore, but the sun, it gets warmer as you go closer to that source of energy. Okay, but then at the top of the stratosphere, once you move away from that, the influence of the ozone layer, you suddenly go in, not suddenly, you then move into the mesosphere, and temperatures decrease again. Thin atmosphere up there, very far away from the ozone, the heating effect of the ozone, and so temperatures again decrease with altitude. Okay, and that's the layer that has the coldest temperatures in our atmosphere. And then again, you would think, oh, well, that just continues all the way through out down to the exosphere. But it changes again, and it suddenly starts to suddenly, it then starts to increase again when you reach the thermosphere. So the thermosphere is also not very dense, so there's not many air particles up there, but much, much closer to the sun. And so as you move with altitude and getting closer to that source of energy, remember the sunlight and the energy from the sun has travelled through space and nothing much has happened through it because it's almost a vacuum space. When it hits the very some of those air particles in the thermosphere, it actually heats them up. That energy is heated up and re-radiated as heat energy. And so the closer you get to that source of energy, the sun, you get hotter and hotter temperatures. And so as you then increase with altitude, because you're getting close to the sun, the temperature of the thermosphere increases greatly to many hundreds of degrees Celsius. Once you then move into the exosphere, the same sorts of things happen, is the temperature also increases, again, because you're getting close to that source of energy in the sun, but it's so less dense out there that in fact the temperature of the exosphere changes through the day. When that part of the atmosphere is pointing towards the sun, temperatures can exceed 1400 degrees centigrade. At night time, the temperatures drop rapidly because there isn't a large amount of air up there to hold that energy and can drop down to 0 degrees. So it changes diurnally very rapidly. Okay, so that's our layers of our atmosphere.